And after understanding generic and enum, one more basic concept you need to know is about uh, TypeScript modules. Already in JavaScript, you know about modules. The same in TypeScript also, module concept. So what is a module? A module, what is the purpose of module? Why we need modules? In JavaScript, you have seen already working with modules. The same concept here also. Technically, a module is a set of values, functions, and classes. Here, values, functions, contracts, templates, so components, etc. It is a set of values, functions, contract, templates, components. Already in JavaScript, you have used modules. Same thing here, we need to do that. What is the purpose of module is? What is the meaning of module? We call it as modular. Modular means part by part. So modular approach module approach allows to build lightweight applications. Modular approach allows to build lightweight applications. That means actually you can import application specific library. You can build and import. You can build and import application specific library. Actually, it enables reusability, maintainability. Reusability, maintainability, and testability. Reusability, maintainability, and testability. Actually, this is same how you learnt in your JavaScript, because in JavaScript generally what we do is, I think I already explained while learning about classes and all. In JavaScript, usually what we do is, for example, what is the concept of module system is, for example, we are creating one JavaScript file. So let's say I am adding a JavaScript file, demo.js. And in this file, we have function. Hello is one function. And it will return some functionality. Hello TypeScript something. We have another function, add, and it is returning a plus b. Like this, we are having some options. We have a function, some multiply, and it returns a asterisk b. So we want to use these functions in this page. That means we are having a HTML page. In this page, we have to use those functions. Generally, what we do, when you learnt your HTML JavaScript, you will usually link the JavaScript file script and a script source, that is ./demo.js. When you link this demo.js, then you can access all the functions. But this is not good way. Generally, you will learn like this, but in reality at high level, this is not good way. Why this is not good way? Because you are linking a JavaScript file with the three functions. But in this page, I want to use only add function. That means here I want to use only add function. So to just use add function, why you are importing entire file? That means why you are importing other functions also. What is the problem in this approach? Generally, we call this as legacy approach. We usually call this as legacy approach. This is an legacy approach. In computer programming technologies, legacy approach is nothing but complete library is loaded even to handle a small functionality. Actually, your technologies like Java, .NET, all these earlier was legacy only. From past 5-6 years, they changed themselves into modular. Earlier, every technology was legacy. Even Java, .NET like technologies are legacy. Legacy means you have to import everything in order to use a small concept. That means this is not a good approach. Why? You are importing a complete JavaScript file with the three functions, but you are using only one function. Then what is the good approach? Modular. Modular means import only the function that you need from that file. You don't need to import every function. This is legacy approach. So we need a modular approach so that advantage application becomes lightweight. Application can easily run with less memory. Otherwise, it needs lot of memory because it need to load everything. That is actually meaning of module. Module meaning is part by part. The meaning of module is modular. Modular means part by part. That means it will not use legacy. What is advantage of that? Applications become lightweight. Applications can run on low memory. Application specific library will be there. So then what is the correct way? This is not good. Generally in JavaScript, what we do, we will use a script and the script type we will set as module. And what we can do, so if you want to import these functions, you have to mark them as export. All these functions need to be export. We need to mark them as export. And what is advantage now? We have to just import. What to import? We have to import add and from / in demo.js. This is not going to load all functions. It is going to load only one function. So now document.query selector, we access the paragraph inner HTML. We display edition. Edition is equal to, we can access add function, into that we can pass a value. Now this time the script type must be module. And when you run this, now JavaScript module system is working. This is how we use JavaScript at higher level. At higher level, JavaScript is used like this. Generally, we don't link JavaScript files. We create a module system, we import only what is needed, and we use it. Even Bootstrap, jQuery, everywhere, even your Angular React also using module system only. That means you have a React library, you have a React DOM library. You are not using complete library every time. You are importing use effect, you are importing use state. Means what? From the React library, you are importing only the functions that you are going to use. This approach is called as what? Modular approach. So this is a very general JavaScript concept. Same here also. TypeScript modules also work in the same way. So every TypeScript file is a module. Every TypeScript file is a module. So members of module members of module are private in access. Members of module are private in access. So you have to mark them as export in order to access from other modules. You have to mark them as export in order to access from other modules. That means like export function name, like export class name, like this we need to define. And already you know any module allows any one member as default export. You know that module allows any one member as default export. In a module, one can be default. So you can import and use the functions, classes, variables from another module. So you can import and use the functions, classes, and variables from another module. So we have import, so name from module. That is the module name. So this is the module system. So how these module system work, you already know. What you know is to use module system, so you have to set up a module system for project. You have to set up a module system for project like common JS, UMD, AMD. So require JS. All these are different module system. ES module. So by default, you saw that our React project when we created, in the beginning, we learned how to create a React project manually. Which module system we were using? UMD. When we manually created React project, we installed React libraries. I showed you there. So we have common JS, CJS, and UMD. But React by default works with which system? UMD, because currently our server side module system is Node.js. Node.js by default supports this UMD. That is the reason we used UMD in the beginning. When we created a React app manually we created so web application. In that web application, when we installed React library, we used from UMD system. That is the module system we are having. Right. So let's see one example how to handle with module system, how we manage. So we will create one environment here, means how the module system is designed. So what I am doing is I'm removing these files, all of these files. Okay, just only tsconfig JSON is present. We will add a folder. One folder is library. And we will add another folder that is app. We have two folders. One is library and app. In the library folder, we are creating again subfolders. One is contracts. And we are creating another folder, templates. And we are creating another folder, components. That means we have contracts, templates, components separate are there. Now let's go to the contracts and we will add a new file. This is a product contract. Product contract dot contract.ts. And in the product contract, so we are using export. We are creating an interface. Why? Because anything in a module is not accessible outside if you don't mark it as export. We have to mark as export. Interface, product contract. Okay, this is having name, price, quantity, total. So total is a function and print. Print is also a function void. This is the contract we are having. That means all the contracts are now maintained in separate files. So this is the contract. In contracts, we have a product contract. Now we will go to templates and we will create a file, product template .ts. Now in this product template, we have to import the contract. How do we import the contract? Import product contract from contracts. From contracts, we are importing the product contract and we are creating export abstract class that is product template. And this product template implements product contract. That means it should be designed according to the contract. Separately, we learned them. Now we are combining all through module system. Separate files, we are defining that. We are building a library to reuse. And what should be there? Public. So name, string type, and it is empty. That means we are configuring some empty. Then we have a public price, it is a number type. It is 0. Public quantity, this is a number type, that is also 0. And public total is a function, so which is a number type. That means it should return this dot quantity into this dot price. Okay, now we have another public. We will do one thing. These we will implement later. Then what we do? We will make them as abstract. Abstract total is a function which should return number, but the functionality is not defined. And again, abstract print is a function. It is a void type, functionality not defined. Now we have a template separate. So we have contract separate, template separate. Now we will go to component. In the component, we will create a product component. Product component.ts. Here we are importing that product template. Product template we are importing. And what we do? Export class and product component. This product component class extends whom? Product template. It will extend product template. And according to the template, so we have a name, some name. So we have price, some price. And we have quantity, that is some quantity. Total is a function and it should return this dot quantity into this dot price. And the print is a function, so which is void type, and it should return console.log all the details like name, this dot name, and price, this dot price, and quantity, so this dot quantity, and total, and this dot total. These are all the details we are having. Now your library is ready. That means we have contracts, we have templates, we have components. Now I want to use this library in my app. That means usually our app will have an index.ts. And here I want to use that library. Just what we do, import product component from the components. And what we do, we create an object for that component. And through that component, we can access the print method, which can print all the details. That means now our application is using only that component. But component is built with template. Template is built with the contracts. This is how you are using all libraries in your Angular or React application. That means you are importing Axios. You are using some events. For example, you are using, we learned already synthetic events. I showed you the hierarchy of synthetic event. That means on-click is derived from some mouse button events. Mouse button events derived from event handler. Event handler is derived from synthetic event. Synthetic event is derived from synthetic event base. I showed you the hierarchy. That means we learned that all React events are derived from a synthetic event base. But you will see only the event in the front end. In the back end, it is built with all the library. That means a complete library is built in this way. Now you just run this index.js. And remember, index.js is in app. We have to run here. So what you do, open in integrated terminal. That means open the file location correctly. So your file is in app. Make sure that you are in that app folder. Now we have to use tsc. What is it? Index.ts. Now, what is the specialty of module system? It uses a DI mechanism. DI means dependency injection. Dependency injection mechanism, where the object knows what are its dependencies and it will compile all the dependencies. Now, what is the specialty here is actually every component needs a JS file, contract needs a JS file, template needs a JS file because you designed only TS. Now, what index.ts will do, it will identify all the dependencies and it will compile them. That means you need to just run tsc index.ts. Then you see that it is going to execute and it is going to generate JavaScript for everyone, for the contracts, for the templates, for the components. Why it is generating JavaScript for all of them? Because they are all the dependencies of this index.ts. Now you can observe your index.js file. Of course, it is working node index.what.js and it will show you the result. It will show you the result. And index.js, when you observe, index.js contains this logic. And currently it is using a module system called ES module. It is using a module system called ES module. And through that module system, it is importing libraries and using. This is generally the JavaScript that is created for your index. And of course, you see the contracts JS. Contract JS is doing this. You cannot see the complete logic what is there. Everywhere you cannot see that. You can see this is, I already told you now, you cannot understand this because several implicitly generated logic will be there. Here only output will be there. So much logic is internally generated and it is defined. So usually this is the concept of module system. Module system advantage is it enables reusability, easy extensibility, maintainability, and testability. So actually module system uses dependency injection mechanism. Module system uses DI mechanism, dependency injection mechanism, dependency injection mechanism. It uses the DI mechanism, dependency injection mechanism, which enables easy reusability, extensibility, and testability. So, example, I will copy that entire example what I done. So what you need to do is add two folders, add the folders. One is library and app. Next in library, contracts. In that we have product contract.ts. The code I will post. So let me copy the code. This is the contract. I will post this code. Another one is library templates. In templates, product template.ts. This is the template related code. Another we have library components. And in that product component .ts, product component .ts is this one. We have a app index.ts. In app index.ts, this is the logic. After that, run compile. So tsc index.ts, node index.js, ts and js. So this is the basic approach of module system, how we handle a module system. So we are creating a module system so that we can easily import only what is needed for that application. Actually, all JavaScript based technologies follow this module system, both client side as well as server side. Server side also. Server side Node.js and all who use JavaScript, they follow this module system. Now, in TypeScript, they have a more higher hierarchy called instead of using directly module system, they use a higher hierarchy called namespace. They use a higher hierarchy called namespace. Namespace is not possible in JavaScript and other technologies. Namespace is possible with TypeScript. It is not possible in JavaScript. It is not possible in JavaScript. But TypeScript can use this namespace to handle more better performance. Actually, while building library, one problem comes. What is that problem is? Actually, you learned JavaScript. Can you tell me one function that you came across in two different libraries? In JavaScript, any one function that you came across in different libraries. Two libraries different, but function is same. In JavaScript, any one function that you came across in two different libraries. So many are there. You have string. String have index of. Array is also having index of. String have slice. Array is also having slice. String have length. Array is also having length. Right? That means two different libraries, but using the same function. That means if I say length, length is which one? Array length or it is string length. Index of, is it index of a character or index of an element? That means in real world development, this problem is very common. We will have different libraries, but function name will be same. If function is same from different libraries, then ambiguous issues will come. Implementing issues will come. For example, suppose we are having a project. So we are having one project. In this project, so two teams are working. That means two teams are building. This is a project and we are having two teams. Suppose we are having team 1 and a team 2. Just roughly. Team 1 have designed a class 1. In this class 1, they have some print function. Now, team 2 also have same class 1. In that also they have a print, but both functionalities are different. Both functionalities are different, but class name is same, function name is same. Now what I have to do is I have to import. I have to import. We have to import. So we have to import print. Print. We have to import print from what is it? Class 1. Now this class 1 belongs to whom? Okay, you given detailly like team 1 class 1. That means team 1 class 1 print. Okay. You are again importing another print from this is from where team 2 class 1. Team 2 class 1 print also you are importing. And you are using this print in your logic. Now which print it will use? Your importing is okay, no problem. Why importing has no problem? Because you clearly mentioned that it is from team 1 and this is from team 2. Now how the print works? Now we have a problem. That means it is confused. Are you calling print from team 1 class 1 or team 2 class 1? This is very common issue that you will come across in large scale applications. When we are building large scale applications, lot of libraries are there generally in your technologies. They have same name functions. Then ambiguous issue will come. Now to overcome this issue, TypeScript have a namespace system. What is advantage of namespace system is it can clearly classify and it can clearly import exactly what you need. And it can reduce the ambiguous issues. It can reduce the ambiguous issues. So namespace is actually a collection of subname spaces, and it is a collection of classes, interfaces, means contracts, templates. That means it is higher than module. That means module is a part of namespace. Namespace is a collection of modules. Module is a collection of members. Members like classes, functions, variables, and all. Namespace is a collection of modules. What is advantage is you can reduce the ambiguous issues. You can import and implement only what you need for your application. Let's see how this works, how this namespace system works. Actually, all libraries of TypeScript based technology are built with namespace. Not only TypeScript, actually this namespace is a concept of Microsoft languages. Microsoft, all languages use this mechanism. They use a namespace mechanism in their .NET languages, in other languages of Microsoft. They have this namespace system, and even TypeScript also uses. As I told you that your React Angulars are built with TypeScript. They are built with TypeScript. Their library is designed with TypeScript. They completely depend on this namespace system. So how this works, let's see. So what is a namespace? Actually, a namespace is a collection of subname space and modules. It's a collection of subname space and modules. It is a collection of subname space and modules. So it enables to configure a library for module system. A library for module system. So large scale applications use namespace for building library. Namespace for building library. It allows to reduce in library, ambiguity issues in library. That is the basic point actually. But how we configure actually syntactically, we have a namespace and parent. We have a namespace child. In this members means like classes, contracts, templates, classes, components, like this. Now, how do we use it? You have to import. You have to import namespace using /reference directive. /reference directive. By using a /reference directive, you have to import the namespaces. You need to import the namespaces by using /reference directive. So you can directly use the members of namespace or define an alias name. LET alias name is it. We need to actually use import. Alias name is equal to parent.child.member. We can directly use it or we can create an alias names. We generally call this as aliasing of namespace. Aliasing of namespace. Now, compiling a library with namespace is also different. So, to compile the library with the namespace, you have to use the command tsc hyphen out file. tsc out file and file.js and file.ts. Actually, recently this command changed. Earlier, they used to have different command for compiling namespace. Now it uses a flag called out file. You have to use out file flag for compiling. Now let's see how the namespace system works. That means more higher than library of module, we have namespace. So how same concept, same example, but this time let me again delete all this. We will create again a new one. Okay. So okay. So we are creating, achha, this file is still open now. Locked, sign, no problem. So I'm deleting these files. Okay. Now we will create the same folders again. Same folders again. What is the folder is? One is app. Another folder is what? Library. In library again folder. What is that? We have contracts. Okay. In the library we have another. What is it? So this is templates. Okay. What is next? In the library we have components. Okay. We are configuring again these options. Fine. Now what we need to do is in the contracts, we have to create a contract. Let's add a new file, product contract .ts. This time, how you build a namespace system is we have to use namespace. Namespace name is project. That is the main namespace. You can give any name. That is the project. And in that, the namespace, this belongs to team A. This belongs to team A. That means team A, their library. Team B, another library. Like that we can separate. Here I am just using, in the project we have contracts. That means contracts is a namespace. And these namespaces must be accessible outside. So you have to mark it as export. And this also should be marked as export. In this contracts, now we have to put a contract. That means we have to export interface product contract. This we need to define. Now the members are same. Name is string type, price is number type, quantity is number type, total is a function with number, and the print is a function with void. This is the way of designing library. That means more classified. That means in our project, we have contracts. In the contracts, we have a contract. That is the hierarchy of designing a library. Now, similarly, we will go to the templates now. And we will add a new file. What is it? Product template.ts. And in this product template, first we will create a hierarchy namespace. This is project. Project is the main namespace. And in the project, we have another namespace. And that namespace is templates. Templates is the namespace. We have to mark them as export and mark them as export. Okay. In this namespace, we will have an abstract class and the class name is product template. This product template, so export abstract class product template. This template should implement the contract. Then how do we import a contract in a library of namespace? In a library of namespace, to import any another library, you have to use // reference. Reference is a directive. This / reference directive will have a path. Path is equal to what is the file. Where is the contract file? Contract file is outside the current folder. That means // in that what? Contracts. In that contracts, what is the file name? Product contract dot what? TS. That is how we have to import. Now what is the specialty is here. Now this template have to use the product contract. There are two ways. It implements how to access product contract. Generally namespace based libraries have two mechanisms. Aliasing, fully qualified. Fully qualified means complete library you mentioned, hierarchy. Or aliasing means put a shortcut. Through that shortcut you can access. Fully qualified means what is the main namespace? Main namespace is project. In project, what is the child namespace? It is what? Contracts. In the contracts, what is the name? In the contracts, we have a name. What is the name? Class name. Class name is what? Product contract. We need to define like this. That means in the contracts, we need to define the product contract like this. This is how we need to define fully qualified. This looks very lengthy. It shows error because you know all the members of contract must be implemented. This is lengthy. What is shortcut? We have aliasing also. Aliasing means we can import. And import is product contract. Okay. So from where to import? Project. In the project, we have what? Contracts. In the contracts, what we have? Contract name. What is the contract name? Product contract. We can define in this way. Right? Actually, it is showing it says that namespace has no export member contracts. That means you have to make sure that all are export. It is having export, there is no problem. There is no problem in that. Just we will run this, it will execute, right? Yeah. Next, what we need to do this time, it should implement. Implement which one? Product contract, it should implement. It is implementing the product contract. Now let's run this. So in the contract, so we have namespace export, contracts export, another one is product contract. We need to define this and specify. Okay, now once you put a aliasing, you can import it and you can use it. Now here you know how to implement that. What to implement here? So we need to implement public name. It is what type? String. Another one is public. So this is price. This is number type. Public quantity is what type? Number type. And abstract total is an, so public total is a number type. It is a number type. So public abstract total is a number type. Okay. Another one, public abstract print is a void type. So your contract is ready. That means your template is ready. Now we need to design a component. How do we design the components? We have product component dot what? TS. we are creating product component TS. And here we have to import triple slash, what is it? Reference path. What is it? Dot slash. It is in where? Templates. This time it is in a folder called templates. In the templates folder, we have a product template.ts. Now we need to import product template. We are aliasing is equal to what we have to do, project. In the project, we are having, project, we are having which one? Templates. In the templates, we are having another one. What is it? Product template. Okay. Now, once you import this, now we need to create export. So this is export. What we have to do here, we need to define a component. Again, same approach. What is it? Namespace. Namespace is what? Project. In that, again, export. Okay. Again, export. Export is what? Namespace. This is related to what? Components. In the components, we have to export class. What is it? Product component. Product component extends. Extends which one? Product template. It is extending the product template. And if it is extending product template, we have a name. So name is some name. We have price, some price. So we have quantity is same. Logic is same. Quantity is some 2. And total. And total needs a total is a function. And it should return this dot quantity into this dot price. And print is a function which will be void console.log. It should print the details. So name and price, this dot price, and we have quantity is this dot quantity, and we have a total, this dot total. All the options are ready. This time we are using a huge hierarchy of namespaces. Now we want to use this in our app. That means we will go to app and we will add a new file. And what is that file? The file is index.ts. Now here we have to import / directive reference path actually / in that library, in that what? Components. In the components, which component we need? Product component .ts. We have to import that. Now we need to create an object. But to create an object, first you have to import. You have to import product component from which location? From the project. In the project, we have the components. In the components, we have a product component. Now what we do, let obj is equal to new product component. And through obj, you can access the print method to print the details. That is the complete hierarchy we need to build by using namespace. And now we can start using it. But remember, if I compile tsc index.ts, it will compile only this. It is not going to compile all these libraries. Then it will fail. Then what will happen is, it is not module system compiling, but namespace it will not. Then only this code will be translated. Then all dependencies will be missing. It cannot work. So what is the command you have to run? in the app folder, you have to run the command. What is the command? tsc hyphen, what is it? Out file, index.js. What is the location? Index.ts. That means in this file, whatever dependencies are linked, references, those references, what out file will do is it will generate an output for all of them and it will put in index.js. Otherwise, if you just use tsc index.ts, only this file related logic will be translated and dependencies will be missing. All the dependencies logic is not created. I will show you. Let's see. tsc, what is it? Index.ts. Then what happens is it is going to translate that index.ts. It is going to translate. All the files are compiled. Compiling will work, but dependencies are not added. Observe carefully now. We go to index.js. In that only component dependency is there. Component dependency is there. And when you run this here, node index.js, it will show an error saying that project is not defined. It is not available. The component is not there. But what is the correct way of translating this? The correct way of translating this is what? We have to use the command. What is the command? tsc hyphen out file index dot what? js, index dot ts. It will generate the out file and it will create the out file. Now, once it is created, it is showing lot of errors. These are all related to dependencies. There is no problem in that. Let's check the file. What is the file? Index.js. And I will run this here. So node index.js. Some problem. This out file is not generated. Let's check. tsc out file and actually it is index.js index.ts. Okay, now it is there. It is still not there. It is still not having the reference. It is using a common JS module system actually. Let me compile this again. Index.js, index.ts. Still it is having problem. Project is not defined. Let's check. Anywhere we missed import, export. It is a, first we will come with the contracts. Export this project contracts, product contract. Okay, in templates, all are exported correctly, right? Why it is having a problem? Product contract, components, template, reference is also correct. Actually, it is already in use. It is saying, let's close this once. Okay, let's add this one more time. This is our TypeScript project. These libraries are correctly generated. Let's check the problem in this one. App. Okay. In this app, we are having index.ts, reference, and the reference path // library in the components product component.ts. Import product component is not required. Component from project. In that components, app, see out file, index.js, index.ts. Actually, this is enough. Let's put a fully qualified here, new project. This is from components. In the TS. This is in the template. Not required. Actually, there is no problem in this. This is the way it has to implement. There is no issue in this at all. We don't need to import also actually. We just need a aliasing name. Components, templates. Import project. So somewhere any one file is missing with the implementation. I will. Okay, let me delete these JS files. Okay, so here some problem is there in this node index.js. Let me check what is the problem, because actually in our approach and our logic there is no issue. Everything is same, right? There is no need to change anything. Let me check once, is there any change they have made in the namespace execution in the latest version, because we installed the latest version of TypeScript. Is there any change they have made in the compiling of namespace? Because this is what generally we do. There is no change in this. Exactly, it has to work with this. Let me check. I will check once. So what is problem in this? No? Then I will check, and tomorrow I will let you know about this. And in tomorrow's session, now we will start building a React project with TypeScript as a language. Tomorrow we'll see that. Okay. I will check this and tell you. Tomorrow we'll see that. Okay. Right.